Alright, in the previous video we learned about the quadratic factorization and we saw how quadratic factorization help us to find the roots of a quadratic equation. In this video, we will see another use of quadratic factorization. You have to find the values of x such that this expression is equal to 13, or you have to find the all values of x which satisfy the given expression. You could think like by multiplying x plus 1 and x minus 3 on both sides to get rid of fractions because we don't like fractions. You might think like this. But if you see by another approach and that is by factorization, if you see the numerators closely, you can factorize these quadratics like x square minus 2x minus 3. You have to factorize this quadratic. Here the leading coefficient is 1, and when the leading coefficient is 1, you have to find out here two constant r and s. Let's say r and s whose product is minus 3, this constant, and their sum is r plus s is equal to the coefficient of your linear term, that is minus 2. So you can think by factorizing this constant minus 3, and the product is negative, so the two constant must have opposite sign, and on sum you have minus 2, so the larger value must have the negative sign. So minus 3 and plus 1, these are the two constant. Minus 3 multiplied by plus 1 is equal to minus 2, and by minus 3 plus 1 is equal to minus 2. Sorry, this is minus 3. Okay, minus 3 times 1 is minus 3, negative 3. So you got two binomials, x minus 3, x plus 1, whose product is this quadratic. All right. Similarly, you can factorize this quadratic, which is x square plus 5x minus 24. So you may think by two binomials whose product is this quadratic. Okay, so you will put x here because x multiplied by x will be x square, and now you have to find two constant r and s whose product is this constant minus 24, and whose sum is r plus s is equal to this constant, the coefficient of linear term, that is 5. So the product is minus 24, so the two constant must have opposite sign, and on sum you have a positive number, so larger constant must have a positive sign. So 8 times 3 is 8 times 3 is 24, so you have to adjust this negative sign, so 3 will be negative and 8 will be positive because 8 plus 3 must be equal to 5. If you take 8 negative and 3 positive, you will get negative 5, which is not required. All right, so these two quadratics can be replaced by their factorization in your question, so this will make your question much easier. You can see here. So replace your quadratics by these binomials x minus 3 times x plus 1 divided by x plus 1, plus on the other hand you have x square plus 5x minus 24. It will be replaced by their binomials x plus 8 times x minus 3 and divided by x minus 3. Okay, which is equal to 13. Now you can see here x plus 1 and x plus 1, these are common factors, can be cancelled out, and x minus 3 and x minus 3, these two factors are common, can be cancelled out. Okay, so you are left with x minus 3, you are left with x minus 3 plus x plus 8 is equal to 13. So by removing parentheses, you have x minus 3 plus x plus 8 is equal to 13. So combining the like terms are x with x, x plus x will be 2 times x, that is 2x, and minus 3 plus 8 is plus 5 is equal to 13. Now subtracting 5 on both sides, you are left with 2x is equal to 8, and dividing both sides by 2 to isolate x is dividing by 2, you have x equal to 4. So this x equal to 4 is the value that satisfies your original expression, that is x square minus 2x minus 3 divided by x plus 1. You can see by putting x equal to 4, you will get left hand side equal to 13, because right hand side is 13. But here you can see something interesting, and that is x plus 1. Here x plus 1 is the denominator of first fraction. If you put x equal to minus 1, it makes the denominator of first fraction is 0. And if you put x equal to plus 3, it makes the denominator of second fraction is 0. So you can't divide by 0, because in mathematics divisibility by 0 is not allowed. So x is not equal to minus 1 and x is not equal to 3 here. So these two values initially you can guess can never be the solution of your expression. Alright, so keeping all these things in mind, we have another question, and that question appear in a competitive exam, that is American mathematical competition. Alright, and you have to find the values of k. For what values of k does the equation x minus 1 divided by x minus 2 is equal to x minus k divided by x minus 6 have no solution for x? Actually, you have to find the values of k for which this equation have no solution for x. Something that you can guess, just pause the video and you have to solve it by yourself, and then we are going to solve it together. But first pause the video and try to solve it by yourself. All right, you can see here, if you put x equal to 2, the denominator of left hand side becomes equal to 0. It means x equal to 2 is not allowed, because divisibility by 0 is completely invalid in mathematics. And if you take x equal to 6, again the denominator of right hand side becomes equal to 0. So you can't take x equal to 6. So these two values initially we just guess are invalid solution, and sometimes we say it extraneous solution of your equation. Now you have to find the values of k for which x is x, there is no x. Actually, in simple word, I want to say, if you you have to find the values of k for which there is no x. So you have to find x in terms of k, and then by on the basis of k we will decide the value of x. So you have to find here the x. You can write the above expression as x minus 1 time x minus 6 is equal to x minus 2 time x minus k. You have to expand the product on left hand side and right hand side. You have x will be multiplied with this one, x minus 6. If I say it, let's say s, and on putting a x equal to x minus 6 back, you will have x time x minus 6, and similarly you have minus 1 time x minus 6, and same here you have x time x minus k and minus 2 time x minus k. All right, now you will see on further expanding, on the left hand side x will be multiplied with x will be x square, and on multiplying with minus 6, so x time negative 6 is negative 6x, and minus 1 time x is minus x, and minus 1 time minus 6 is plus 6. On the right hand side, x time x is x square, and when x will multiply with minus k, it will become minus kx. By default we write constant before the variable. All right, now minus 2 time x is minus 2x, and here minus 2 time minus k is plus 2k. All right, because you have to find the x, so you have to group the terms having x on the one side and the terms without x on the other side. So terms having x will be on the left hand side, x square, minus 6x and minus x will be minus 7x, and this 6 will be on the right hand side. It will go on the right hand side because it has no x, so this x square will come on the left hand side, x square, and minus kx will be here, plus kx, and minus 2x will be here again, plus 2x, and on the right hand side we have 2k, and this 6 when come on the left hand side will become minus 6. So x square and minus x square, combining these two terms together, they will produce 0 by additive identity. X square minus x square, it will be 0, and minus 7x and plus 2x will be minus 5x, and this is plus kx. All right, so on the right hand side we have 2k minus 6, and the symbol on left hand side is this implies that. All right, so if you don't know this one, now the left hand side is divisible by x, so you can take x as a common, so x is the common here, it will be k minus 5, just writing the positive term first and negative term later. All right, so it is 2k minus 6. Now you have to find x dividing by k minus 5 on both sides. You have x is equal to 2k minus 6 divided by k minus 5. Here you can see, you can observe, just pause the video and try to guess what I am going to tell you. Because if you put k equal to 5 here, if you take k equal to 5, if we take k equal to 5, the denominator becomes equal to 0, because 5 minus 5 will be 0, and you can't divide by 0 because divisibility by 0 is not allowed here. All right, so k is not equal to 5, because if you take k equal to 5, you will get no x for the corresponding k equal to 5. So this is our first value of k, for which the given expression have no solution for x, because if you take x equal to 5, you will get nothing for the x. All right, so k is equal to 5 is the our first value. If you go back, so k equal to 5, k equal to 5 is my first value, for which the given solution have no solution for x. But you can see, if we take x equal to 2 or x equal to 6, because which cannot be taken, if some value of k produce x equal to 2, if some value of k just produce the value of x equal to 2, so this expression will have no solution, because when we take x equal to 2, the denominator becomes equal to 0, and by 0 we can't divide. So if we take x equal to 6, again the right hand side denominator becomes equal to 0, and again we have no solution. So we have to check out, is there any value of k which produce x equal to 2 or 6 or not. You have to check out. Okay, so k is equal to 5 is not only the single value of this question, you have to check out. So first we take x equal to 2. When you take x equal to 2, this x, when you take this x equal to 2, you have to find out, is there any k. If there is any k which produce the value of x equal to 2, we will say that for that k the given expression have no solution. So on multiplying by k minus 5 on both sides to get rid of a fraction again. 2 into k minus 5 is equal to 2k minus 6. So 2k minus 5 is equal to 2k minus 6. So adding 2k or subtracting 2k on both sides. If we subtract 2k on both sides, subtract 2k on both sides, you will get, here is minus 5 and here is minus 6, and minus 5 can never be equal to minus 6. So x equal to 2, there is no such k which which violate our expression. All right, now you have to check the second value of x, which is I think 5, which is equal to, no, it's a 6. All right, this one is the 6. Now you have to check x equal to 6. So if we take x equal to 6, we have to check 2k minus 6 over k minus 5. Is there any k for x equal to 6? Because if there is any k, we have to eliminate that k, because that k will produce x equal to 6, and x equal to 6 makes the denominator of the original expression equal to 0. So you must eliminate that k. Now multiplying both sides by k minus 5, 6 times k minus 5 is equal to 2k minus 6. It is 6k minus 30 is equal to 2k minus 6. So subtracting 2k on both sides, it will be 4k, and here will be minus 6 plus 30 will be minus 6, 30 minus 6, it is 24, and here is 4k. Now dividing on both sides by 4, you are left with k equal to 6. If I am not wrong in my calculations, so 6k minus 30, 2k minus 6, and 6k minus 2k is 4k, and minus 30 will be here. 30 minus 6 is 24, so k is equal to 6. All right, so I hope I am correct in calculation. So this is the value of k. If we take k equal to 6, x will become equal to 6, and if x become equal to 6, our original expression has no solution, because x equal to 6 makes the denominator of this fraction equal to 0, and we are unable to divide by 0. So there are two values of x. One is x equal to 5, and the other is one is k equal to 5 and the other is k equal to 6. So these two values, k equal to 5 and k equal to 6, are the values for which this expression have no solution for x. All right, if you have any query about this question, if you have any question regarding this, or if you want PDF notes of this lecture, you can comment in the box. Inshallah, I will provide you, and if you have any question, you can comment in the box. Stay blessed, stay happy. If you learn something, if my videos are interesting for you, please like and subscribe and share with friends. Take care, stay blessed. Allah.